Greetings. My name is Mike. I'm here with my colleagues Tong, Josh, Mark, and Saikong. And today we're going to be presenting about how our relational database can help improve the business operations of Block 15 Brewing Company. Now, for our agenda today, I will be providing you all with an introduction to our project, which will be followed by Mark, who will be discussing our data information as well as our entity relationship diagram for our database. Tong will discuss our access tables and provide some sample data. And then Sikong and I will then be covering the implementation of our database, walking through a few examples of our sample data to give you an idea of exactly how our system works. And finally, Josh will be providing an executive summary as long as with our team contributions to conclude the presentation. Now, to start, Block 15 has proudly become a staple in the Corvallis area as the first brew pub opened in 2008 in the downtown area. With success came the launch of the second restaurant, Caves, in 2013, and then the production brewery and tap room in 2015 in South Corvallis. Serving locally sourced and casual food paired with super fresh craft beer, Block 15 has been fortunate enough to establish a reputable name in the brewery industry and has become a favorite among locals. The operations of Block 15 have several moving parts. There's the brewery, the tap room, and the two restaurants, all of which have very different functions and operational structures. Block 15 started as a small brewery and restaurant, but has since began to produce signature beers on a larger scale, expanding operations beyond the simple restaurant format. Our key team members begin with our beer promotion team and our serving staff, such as waitresses and bartenders, who are the face of Block 15 since they serve our final products to our consumers. We also have our master brewers and their teams who have perfected their craft in who have perfected their skills in this craft. And then lastly, there's the management team, who we've decided to focus all of our time and energy on since Block 15 has made a great effort in perfecting their beer recipes and their customer service model. And so we felt like implementing a productive system could significantly help management make strong business decisions around operational efficiency and marketing efforts. With that, we have stated 3 problem statements to guide the development of our database. The first being around operational efficiency and trying to determine how many raw materials are required for purchasing on a daily basis. Our second is around retaining customers and attracting new customers, and exactly what do our sales look like in the Corvallis surrounding area, and can we improve our marketing campaigns to identify demographic spending habits. And then our third is about utility reports to strengthen our marketing competitiveness, and we want to know what products should we be offering in our promotions.
Hi, I am Ekapat. I will talk about the data and information. The data is a raw fact and figures. It has no meaning itself. For example, the set of data $7.6, $9, $5.5. Another set 60%, 50%, 40%, and some clauses. For example, sticky hands. So next one is about information. Information is the result of processing the raw data to exploit its meanings. It also requires context to reveal the meaning. For example, I will transform the data I mentioned in previous slide, which I bold in this slide, to the information by adding some context to reveal its meaning. For example, the 3 best-selling menus in restaurant and brewery, it's just the name of restaurant, show the profit of $17.6, $9, and $5.5 consequently. Another one is the profit margin of product ID 2301 is 60%. For 2304 is 50%, and for 2345 is 40%. And the last one, sticky hands, is a beer product made from ale. It sells at $5 and has 60% profit margin for each one. So let's move to the diagram. I also attached the overall diagram in a small picture below all slides for easy to follow my presentation. First one, I will mention about the relationship between customer and invoice entities. A customer can have 0 or many invoices, while one invoice contains only one customer. For the relationship between invoice and restaurant, it shows one invoice contains only one restaurant, while one restaurant can have 0 or many invoices. Let's move to the next one, between the invoice and product. One invoice can have one or many products, while one product can be included in one or many invoices. In this relationship between invoice and product, it shows the many-to-many relationship. Thus, we need to the bridge entity, and I named it as order entity between these two entities. And the relationship will change to be between the invoice and orders. It has one-to-many relationship, while the product and order, it has one-to-many also. For the next relationship is between the product and category. One product can have only one category, while a category can have 0 or many products. And for the next one, I will talk about the relationship between products and raw ingredient inventory entity. This one again has many-to-many relationships, so I add the recipe entity to be a bridge entity. And the business rule is one product can have one or many recipe, and one raw ingredient inventory can have 0 or many recipe. For the next relationship is between the raw ingredient inventory and invoice line. One inventory can have 0 or many raw material invoices, and why one raw material invoice belongs to only one inventory. Okay, to the last relationship, it is between the invoice line and supplier. This relationship again is many-to-many, so I add some products invoice as a bridge entity, and the new relationship shows that between the supply and purchase invoice has one-to-many relationship, and between the invoice line and purchase invoice, it has one-to-many relationship also. Okay, let's move to another part.
Hi, I'm Posawat or Thong. So this is the overall ERD design generated from the business rules that Ekapat talked about. The access tables are created based on this ERD design. However, the tables that are associated with the many-to-many relationship will be explained in this part. Next, this is the final ERD design from the Microsoft Access. We use several SQL codes to create all the tables, and the aggregate functions are also used in this project too. Let's begin with the first many-to-many relationship. This relationship occurs between the products and invoices entities. The products entity describes the product ID, description, the price of each product, and so on. The invoice entity lists the invoice numbers that are associated with each customer. This entity also shows the total amount of money in each invoice, invoice quantity, and also the product quantity. This is the bridge entity that is inserted between these two entities. This bridge entity allows the company to show more details about the total price of each product ID sold to customers. Let's move to the second many-to-many relationship. This is the sample data of products and raw ingredient inventory. The right table is the products table as I described it in the last two slides. For the raw ingredients inventory on the left shows the raw material ID, the inventory remaining, maximum inventory quantity and minimum inventory quantity that block 15 have in its inventory. Here's the bridge entity named recipe. This bridge entity allows block 15 to show the units required in raw material ID for each product ID. This information is very helpful for the company to keep track the number of raw material units required for each product ID. Then let's move on to the next many-to-many relationship. This picture shows the invoice line and supplier tables and their sample data. The invoice line table, which is the upper table, shows the quantity and price of each raw material that block 15 orders from suppliers. The lower table, which is the supplier table, shows the supplier contact information and other necessary details. This is the bridge entity between the invoice line and supplier. This entity allows the company to show the invoice place date and the invoice fulfill date and also the invoice amount in total. All of these information will be helpful for the company to keep track the customer's order from its supplier. Okay, let's move on to the next section.
Okay, to answer three problems we identified before, we conduct 3 business reports. First report, daily inventory and purchasing order business report. This report is run daily by purchase manager. The responsibility of purchase manager to manage the inventory level to avoid any potential loss of revenue due to insufficient inventory. By receiving daily inventory data from each restaurant location, the purchasing manager can use this report to assess its purchasing decision. The report generates a list that contains raw materials that are equal or less than the minimum order quantity. The recommended quantity to purchase shown as purchase quantity, which is calculated by using maximum order quantity minus inventory on hand. This report automates all raw materials that are in stock and do not require ordering, so that this report can quickly help purchase manager to determine which raw materials need to resupply and also help them to reduce the time required for purchasing decision making process. Let's move to the query design. This is a query we made to generate the first report. All the data and the information comes from raw ingredients inventory table. The raw material ingredients table are the original access table we used. In this table, inventory remaining is recorded by inventory manager according to daily inventory remaining count. Maximum and minimum inventory are determined according to previous operation experience. Let's move to the second report. This is the original table. Second report is demographic spending report. Demographic spending report is a monthly report run by a marketing manager. This report helps to identify key information about our customer and their spending habits that can be used for marketing and promotional campaigns. The report displays the quantity of customers visit our restaurant grouped by zip code. It also summarizes their spending by showing their total and average sales. This information is very important to the marketing manager's effort to identify our most profitable customers and exactly where they come from. For example, from the report, we can easily tell that the majority of our customers are coming from zip code 97006. We can target promotional efforts to retain customers in that zip code. To attract new customers, we can adopt a very different promotional strategy and focus on the locations where we do not get many customers. Calculating on average how much each customer from each zip code is spending per month can help us to identify how much customers are willing to spend and how can we develop a specific and appropriate promotional offer. This combined information on this report can be a quarterly or annually, which can help us to get the overall view of the trend through the year and help us develop a schedule plan through the year for our promotional offers. Let's move to the core design for report 2. The data are coming from customer table and invoice table. We sum the total amount of customers spent together, and we use the total amount divided by the count of customers to get average sale per customer. Then we grouped by zip code. Next slide shows the original table we used to generate our report. The table are customer table and invoice table. The data on these two tables are collected by daily transaction and customer reward program. Let's move to report 3.
Report 3 is our monthly top product earnings report. This business report helps identify our top-selling products at each restaurant location, the quantity sold, and this information is ordered by the total profits. We wanted to generate a monthly report that would highlight our most popular profit-generating products in order to strengthen our marketing and promotional efforts. Our second business report helped us identify exactly who and where we need to market to, while this report helps us decide exactly what we want to offer to them. Our SQL queries used for this report are run for each individual restaurant and list the products sold ordered by the total profits in descending order. It utilizes 4 tables to extract the necessary information from our restaurant information, invoices, products, and orders. These 3 queries can be combined to produce the top-selling products report. And once these reports are generated over several months, they can actually be used to develop trends to identify seasonal spikes in particular products. This can be extremely useful in our promotional efforts so that we can send offers to our customers that they will be likely to accept, but at the same time will make Block 15 a healthy profit.
In conclusion, our goals here were to improve operational efficiency, restaurant expansion, and location selection. And 3, strengthen marketing for competitive edge. We did this through the creation of an ERD and development of entities and attributes and relationships between those entities. We then implemented this ERD into a database, and queries were developed. From those queries, we were able to generate reports that improve our operational efficiency, restaurant expansion and location selection, and strengthen marketing for competitive edge. Next contribution to this project, Tong and Mark led up the SQL query development. I led up some of the database implementation, and Saikon did the ERD and conceptual design, and then Mike led up the operations and business report design. Thanks, everyone.